Thank you very much, Moses Frost, for coming on the podcast.
Oh, the pleasure's all mine. Thank you.
You have a seriously impressive track record within multiple security disciplines such as offensive security and cloud security. Nowadays, you're a consultant and researcher, and you're also an author and instructor at the SANS Institute as well. And it was also nice to see that you're a maker of finely made, handcrafted, artisanal, bespoke exploits. And that's very interesting. I would love to hear more about that. So maybe we could just start off if you could introduce yourselves and also your journey leading up to this point in your career.
Yeah, absolutely. So, uh, this is a long form podcast, right? So multiple few hours. We have maybe an hour or so. I'm not sure. So I can go long.
Yeah, sure. Go ahead.
Okay. Well, I'll try to be brief. So I started out in computers probably when I was about 12, and I am going to date myself. So that would put me late 80s, early 90s. So started out just playing around with them. Games, mostly games. We had an elementary school that had Apple IIs, and you play little games and whatnot. Anyway, um, I ended up doing a lot of work, or just playing around with them. And a neighbor of mine, turns out that his brother worked for um, IBM at the time. And I didn't know this until I moved up to my area where I'm at now. But IBM's division for personal computers was out of Boca Raton, where I live now. And so the original PC, the one that everybody would know as the IBM PC, was actually being built out here. And he worked as I think a QA, maybe a developer, I'm not sure. I was too young at the time to ask because he was my neighbor's older brother, so he must have been 19, 20 years old or so. And he worked for IBM on OS2, version 2.1. And so he's techie, and I'm just wanting to play around with computers. I ended up with these friend group, just a bunch of misfit kids, which were just nerds, uh, working like using bulletin boards. And so we started out on bulletin boards and whatnot. Um, and I didn't care to do software piracy or anything like that, but I ended up using an artboard quite a bit. So there was a lot of relationships between the art community and the hacking community and the cracking community and whatnot. And so when you're on artboards, you get to see all these magazines and all these different things, and you get to see like what people were trading for, like fake credit cards, which looking back on it now, it's a very simple thing, what they were doing. But it was different, totally different time. And so that was the stuff that I did as a kid. That's a story in and of itself. That's a long-winded story about bulletin boards. But I started, like, after high school, this wasn't a career, you know. We're talking late 90s and South Florida, and this wasn't a real job back then. I know it's hard to think of it, but it wasn't a real job. So I ended up doing what my dad did, which was I worked on cars, and I was an actual automotive mechanic for a while. I did it as a machinist, so I know how to take apart cars, put them back together. I worked in a machine shop, weird stuff like that. Worked a lot with my hands. And my mom looked at me one day and said, "You really suck at this. You're just miserable. You just don't like this. Why don't you go do something with computers?" And I'm like, "What can I do with computers without a degree? Like, I don't know." So I started working in a desktop job. Like, I built computers for about 6 months or 8 months, and I got my A+, and I got some Microsoft certs, some Novell certs, stuff that doesn't exist anymore. And as it turns out, like, I got an enterprise job. I worked my way from desktop to, networking, and they gave me the firewalls. And the reason they gave me the firewalls was linked to my BBS days. I just didn't have the money for a nice computer in the 90s as a kid, right? So one of the ways that I could run my bulletin board and still interact with people on what was now the internet, was I used an internet service provider who was running Linux. And I said, oh, I want to run Linux. I don't even know what that is. So I went to the bookstore and I purchased a book. That's how you got Linux back in the day. You purchase a book. And so I ran Linux kernel 1.2 off of an old version of Slackware in the 90s. And because I knew Unix, they gave me firewalls. And I just said, okay, whatever that means. And I took a firewall class, and I started my journey into security that way as a network security engineer in the early 2000s, running like Checkpoint 3 or something. And like I look back at what you could do back then and what we're doing now, and boy, it's a different world. It's just different. It's just different. And so yeah, I've seen a lot in my career, and I guess nowadays I look back and I'm trying to count how many years I've been doing it, and I decided to stop counting. So there you go.
Very nice. Yeah, it's been a huge evolution in technology. It moved fast back then, but even nowadays it's just accelerating out of control. And I would love to hear your thoughts about this concept of cloud native. In these last 10 years or something like that, more and more organizations are just moving all of their stuff into the cloud. Used to be you host everything inside of your nice walled garden, but now everything is in the cloud and it's accessible via APIs with identities and permissions and so on. So how have you viewed this change? And I know it's been going on for a while, but what changed and how did that play out? And how do you feel we are standing here today?
Cloud native. Wow, you're just throwing me in at the deep end, huh? Okay, so my journey into cloud. So if you think about what I said about hacking and stuff, right? Um, I didn't think that when I started hacking and stuff wasn't a career. Like if you were a security person, you did everything, forensics and hacking, and it just wasn't a clear cut definition. Um, and so back in the early 2000s, I was more into virtualization and VMware because I ran Linux in the 90s. And if you want to run a bulletin board and you're on IRC, you may or may not know people that gave you copies of VMware Workstation 1.0 to run like MS-DOS. I'm just saying it could have been a thing. And so big into virtualization, right? And I remember trying to start up like some VMware user groups, and we're talking early days. And one day, I see an announcement from Rackspace that they are going to make a joint press release with NASA, and it was around cloud or not cloud, but it was around virtualization. And so basically, what they were announcing in 2004 was OpenStack. And shortly after OpenStack, you saw AWS Web Services, and then from there you saw Azure and all this stuff. And so the early stuff in the cloud was just somebody else was running VMs, right? Now, if you're Amazon and you are having to purchase thousands and thousands of servers, right? It would kind of just make sense if someone's building a server to run an application once a month to not do that, because it's expensive for Amazon and it's expensive for you, right? And so you could see with this idea of, hey, why don't we just give you the ability to like run a little bit of code and not have to worry about like all the server stuff? And so they came up with like Lambda, right? Which makes total sense, right? And containerization, Lambda, the ability for you to use services like databases in the cloud, file systems in the cloud. This kind of is natural into this idea of cloud computing, where you are going to be able to just take a service and expose it, right? And then that's how that whole idea of cloud native kind of came to be. Depends on who you ask, right? If you were to ask somebody at the CNCF, they're going to tell you it's all Kubernetes, it's all containers. It has nothing to do with the vendor services. I don't know. It just depends who you ask. But the idea that you don't necessarily need a server to do a thing, that's important.
Hmm.
Now, you asked about permissions. It's funny, right? Permissions have plagued us even since like Active Directory days, right? Um, Here's how I look at permissions. It's very powerful in AWS to set permissions. It's also so complex that doing it right is almost an art form. In Azure, it's really easy to set permissions in certain places, but doing it right is also an art form because over permissions in both clouds are a thing, and in Google and all of them. And in order for, if you're coming from Active Directory, this is your view of the world. I join a machine to domain. Domain machines can automatically do stuff on the network. Don't join evil machines to domain. End of story. Right? That is the high level view of Active Directory security. Right? Cloud security is more like your server can't do anything. Give it permission so it could do something in the cloud. Right? So it's backwards. But if if you're trying to set permissions on Friday and you're trying to go have beers afterwards or go to happy hour or something or go home, uh, you're just going to set administrator access star on things and take care of it Monday.
Yeah,
Yeah.
exactly. Yeah, because it's been a big change, and as you say, it used to just be someone else's server. Now things are broken down into microservices. The architecture is changing fully. It's very rare that you will find a vulnerability in a serverless function, like in itself, the technology itself, or in Kubernetes or stuff like that. It's more identity flaws, maybe misconfigurations, and so on. Right?
Yeah, if you like just to give the audience an idea, right? So every cloud does this a little differently, but I'm going to pick on AWS. Everybody always picks on AWS. Maybe it's because they were first or they're big or it doesn't actually matter. Because every cloud has a similar kind of issue, right? But in AWS, I did some work where you um, uh, you get uh, uh, it was an attack path that we're modeling, where you get a victim account, and then from there you can assume a role to a specific role. So in AWS, they don't have this concept of a service account. They have this concept of think of it as a service account for now. It makes it easier for the audience, right? But it's something that you can become. It's an object you can become to get more permissions. So if you do that, if you go from account A to service account, let's just say for all intents and purposes, and then take that service account and assume a role as a different account. So now you're actually chaining a few of them. Trying to find that in logs as an incident responder, even when I tell you I did it at this time, on this date, in this particular action, it's really hard for the IR folks to piece this together with logs. It's super hard. So yeah, it's complicated in the cloud. It really is.
Hmm. In
Uh,
one way, it seems so simple as well. You have this one pane of glass, you have this control panel you can click, you can create things with the click of a button. Everything is centralized. You can distribute things globally from one place or via API and so on. But in another way, it also can become a needle in a haystack and finding and addressing these misconfigurations, these abilities to escalate permissions. Yeah, it must be very difficult.
yeah, so it's cloud dependent. Nobody's immune. I would say more people are focusing. It's weird, right? So, a word of advice to the younger viewers, okay? Just because something doesn't have exploits and vulnerabilities attached to it doesn't mean it's safe. It just means no one's looked. So, um, right now, the trend, because hacking is trendy. I just want you to think about that. It's very trendy, okay? The trend at the moment is to find a lot of attack surface in the AWS cloud. There's a lot of research that's been built around that. So a lot of people have figured out how the AWS cloud works. It's a trend. Um, Entra ID and Azure identity has become the trend for finding exploits inside of Azure AD, finding exploits inside of like abusing identities that way, right? So does that mean that Okta is immune? No. Does that mean that Google Cloud identities are immune? Not really. It just means that all the research is focusing on Entra ID. Maybe it's because of market share or something like this, but I don't know. But it is trendy, right? Just like last few years, it's been very trendy for the attackers to go after VPNs, right? Lots of VPN exploits are out there for every vendor. And some of those exploits have probably been there for more than 10 years. It's just nobody's looking.
Hmm. Yeah, exactly. I guess, yeah, as you say, you have identity providers such as Entra. They are, of course, very used. A lot of people are migrating their on-premises, maybe Active Directory environment, making it hybrid and automatically using Entra. It's also very, very broadly used. So it would make sense that more security research has been made there, of course.
Yeah, well, think about this, right? Like every one of these IDPs, I'm going to remove Entra. Let's just forget Entra exists, right? If you've got Okta as SailPoint, Jump Cloud, I'm going to throw in there the Google one, whatever they call it, because it's not Google. It's not Google identity or something. It's not like that. It's like their Gmail thing. And then if you throw that one in there, and for the sake of argument, I'm going to throw Duo from Cisco and a bunch of the firewall vendors, right? All of these devices that install an agent in Active Directory, and they all take that identity and shove it to the cloud in some manner. And if you're synchronizing passwords, that's happening in some manner, right? So all these connectors do it, but the only one you ever hear about being abused is the Entra ID one. Why?
Yeah, it's way more used, I guess. But I've also been seeing more and more research coming out about Okta and stuff like that. And I guess SpectreOps are some of the people who have been focusing more on it. So I guess there'll come out more details as researchers have more time and prioritize their research there.
Yeah, totally. I mean, I think the Spectre folks, they do a great job. They've always done a great job on offensive and defensive, a lot of offensive work. So that's been great. Been tracking them for years. But even they have their own swim lanes that they go into, right? So, um, you know, just because they focus on Okta doesn't mean that they're necessarily going to focus on, say, Jump Cloud or some of these others that I've seen out there. And you can argue that these others that have not been paid attention to probably have a larger, broader attack surface. It's just, when was the last time you saw someone go after the Jump Cloud connector? Probably never, you know.
Hmm. As we talked about a bit earlier, now that I guess the main parameter into people's environments is starting to become identity based. It's not necessarily only firewalls that are keeping people out, and yeah, it's identity. You need some kind of access, some kind of degree of access to escalate further in. So, what kind of ways are attackers, or what kind of techniques are attackers using to gain that initial entry into these large cloud environments that you see? What kind of initial access vectors exist out there?
Yeah, I wish it was. I wish it was hard. Um, so there's been a few reports out there. I know Palo Alto Networks, who is my current employer, uh, they came up with a Unit 42 report around what the initial access methods for some of the breaches that they've seen in the cloud look like last year. Um, MFA, like the actual accounts that were not guarded with MFA, was 30%. But if you look at the rest of it, right, over 70% was just account compromise. So account takeover and compromise is still a thing, no matter how much MFA they're pushing. We're seeing phishing be very effective still. So this idea of phishing is huge. If you are in an organization right now and you want to prevent the simple phishing from happening, I would highly recommend that you look at using a passkey or YubiKey only as your administrator account options. and trying to roll that out to your user base. And if you don't know how, so passkeys, people don't really understand how they're designed to work or why they're phishing resistant. But high level, um, the URL that you're going to is what is used to sign and to basically check for a signature in the YubiKey system. So when you go to Microsoft.com or MicrosoftOnline.com, that URL will have a signature tied into a pass key or a YubiKey, depends on, or I say YubiKey, a FIDO2 compliant key. Just so happens I've used YubiKey so much that I just say YubiKey. But one of those hardware authenticators, and then that URL they'll look in there, you'll match up that URL, and then it'll sign the proper package, if you will. The converse of that is you go to a phishing site that you don't have a signed package for, and the passkey, the YubiKey will never work. So attackers that set up evil jinx and things like that have to do different things. Now, what are they doing? Well, if you have access to the endpoint, right? One of the things you could do is you can reload the browsers in using developer tools or some other techniques to hook the browsers to be able to steal the access tokens from that device and send them over to you. And that's really one of the more primary vectors that attackers are doing, is that they are, once they're on the endpoint, they are persisting by stealing tokens. Now, without your administrator configuring things at all, the default timeouts for every application will be different. So if we actually gain access to somebody's environment, one of the things you might see us do is open up that the console where you have all your apps, whether it's the Microsoft My Applications or the Okta one, and we open up and we click everything, click, 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 click. And the idea is if we click everything and open them up, we'll start getting cookies for every single app, which should have a different timeout. So let's say that you've defined your session reauthentication to 7 days or 14 days, which is the default Microsoft one, right? The default Amazon one for their console is 30 days. So there's an expiration window issue there. Slack, which is always in the news. You ever wonder why Slack is in the news? Slack's default timeouts, if you don't actually change it, is never indefinite timeout. So if you get a Slack cookie, you're in there forever, and that's why you see all these breaches happening with Slack and things like that. Can you change all this? Yes. Most administrators don't know how to change it, right? But that's what we're seeing. We're seeing a lot of that. We're still seeing AWS access keys that are stolen. I saw some research from the folks at Trufflehog or Truffle Security. They did this really interesting thing. They took the training sets of the large language models. So they went to the Amazon, I forget what they call it, Common Crawl training set, which is like 90 terabytes or some crazy number. And they built a little machine that would go in and extract every one of the web archive files out of the training set. And they looked for AWS access keys, and they found several hundred long-term access keys that were like valid or something like that. So still seeing that out there. So there are these things that still exist. Hopefully we see less and less of them, but we also see like wildly insecure systems that are just out there. Firebase from Google can be very secure or very insecure, So if you look, and that's what the attackers are doing, they're just looking for opportunities, you'll find it. I just posted about one called Java Ghost. It's a group that is setting up persistent phishing in the environment, and they're using accounts, just standard IAM accounts for persistence, which is valid.
I just was reminded when we were talking about this opening developer tools and and that the phishing attack vector about the recent huge Bybit breach where
Yeah.
North Korean hackers actually, yeah, it was a crazy event. I think you know the details about that one. I think you posted about it. Could you explain what happened there?
Yeah. So let's talk about North Korea, right? So I've spent some time. I like geopolitics, so I read a lot of geopolitics around the world, and I'm trying to infuse geopolitical events into the hacking scene because they sometimes do line up pretty nicely. North Korea is no exception. So North Korea, their economy, the way that it works inside of North Korea is that if you want to have a computer, you can go to the library and you can go to a bunch of IP addresses. I'm not kidding when I say this. 192.168 addresses on the wall, and that is the different parts of the North Korean internet that you can get to. If you happen to be a party official of a high level, or you happen to be part of their hacking group, then you can have access to the internet. That's the way that North Korea works. Okay. So it's different than other countries where you can argue that a citizen of that country is not part of the military and that they're hacking people, right? Here, it's more clear cut that if you're in North Korea and you're a hacker, 99% chance that you are not a citizen alone, you are a part of the military. I'm just putting that out there. So the way that North Korea's economy has been funded, or one of the ways it's been funded recently, has been through this idea of crypto theft, right? Because they are shielded from the world, and so cryptocurrencies have been part of their economic model for probably a decade now. Hard to tell. Anyway, what happened here was the attacker group that's been attributed to North Korea, which is Lazarus, went in, attacked a workstation from a developer of Bybit, got onto their system, and using the developer's keys, was able to inject a custom version of client-side JavaScript into the bucket, and that client-side JavaScript was stealing or was redirecting transactions into the North Korean wallets. And so they were able to heist about 1.35 to 1.5 billion in cryptocurrency. Now, this is what a third party assessor has stated. There's a lot of rumor, speculation, etc. The cryptocurrency world is kind of weird. So was it an inside job or not? Definitely it went to wallets that are believed to be attributed to Lazarus.
Hmm. The consequences are just so massive. Yeah. So it was phishing, then getting access to a key, then you have an identity to actually make
Well,
tweaks
they
to
got on the
a.
workstation for sure. They got
Yeah.
on the workstation as to that identity for sure. Yeah, yeah.
Mm.
Um, was it just phishing? Hard to tell.
Okay, I see. Hmm.
Yeah.
That's the thing. Once you have an identity, you can modify this. Of course, many organizations are also dependent on these applications, and they serve their clients, of course, their customer base. Being able to modify these applications can have crazy ramifications. So there's this concept of attack surface management. I'm not sure your take on it would be interesting to hear. That's basically mapping out what kind of attack vectors or what kind of ways into a cloud or into a perimeter exist from the internet or something like that.
Yeah. I mean, it's just to give you some background. A friend of mine, a good friend of mine, was one of the early employees at BugCrowd, like number 3 or number 4. And back then, the you could take a look at the marketplace and think of bug bounties as the Uber gig economy for hackers. Okay. Now, what what he saw back then, and what people were seeing back then is it's a very lopsided market. So the top 1% of that model rakes in all the money. Okay, so how do they do that? Well, the way that a lot of these early bug bounty folks did it was they would have to know about a bug ahead of everyone else. And the only way to do that was to consistently keep a track of your top paying bounties by looking at their infrastructure in real time as fast as possible, such that when something changed, you could go back and say, okay, how much of a change was there? And because X amount of the page or a new system showed up, how secure is it? And they would automate a lot of the reporting. Okay, so this concept, this is a foundational concept in attack surface management. The idea is that I can race you and I can do better than a vulnerability scanner that's point in time by being extremely pragmatic, looking for the bugs that matter, right? So attack surface management, this concept, right, is pretty powerful in that instead of you relying on a human to feed a scanner manual data, right, and then from there trying to suss out what's really important, a lot of these attack surface management tools, their job is not necessarily to find all the bugs, because you could do that with Nessus. The idea is that they will take the parts of you that are known to the world, your domains, your subdomains, etc., ferret out the ones that are new or existing, and pragmatically look for bugs. And so this is a different way of tracking bugs because these are just the things that matter. So we can get into a quantum conversation at some point around this, but right now, TLS 1.0, TLS 1.1, TLS 1.2, TLS 1.3 basically unbreakable by your average hacker. There's not a hacker that I know that's like, oh, you're running TLS 1.0, so I'm going to decrypt your data. That's not how it works, right? So why even worry about TLS, that version of TLS? It doesn't really matter, right? Instead, let's worry about the bugs that do matter. Like the SSL VPN that's at the edge that you forgot to patch, that's in a corner of a data center in another country, that's in a subdomain that's called, test DMZ or something, right? Let's worry about that one and not worry about, TLS 1.0, right? At least not right now.
Exactly.
Yeah.
Yeah, so being able to just respond very, very quickly, much faster than an annual pen test or a once in a while security scan. Let's say if a developer publishes some kind of a token into a GitHub repository, that might be attack surface management. Server-side request forgery, which is also a way into a cloud, right? These things can be found very, very quickly using these bug bounty programs, but also, I guess, vendors that are delivering this kind of service.
Yeah, there's a bunch of vendors doing it. Everyone has their own spin on it. What you really want is to look at, I mean, the ones that are going to make the biggest difference are the ones that are going to help you prioritize the problems, right? Because that is our biggest challenge right now. The biggest challenge that I've seen is that CVEs are exponentially growing. We're not writing less software. We're maintaining much more than ever, and we're going to keep maintaining software, especially if AI starts writing sloppy slopware. They're going to just be more issues, maybe, right? So, which vulnerabilities are the ones that are actually going to make a difference, and how do I prioritize that? Those are the attack surface management tools that I think are going to be the most valuable, right? Because generically, they're all going to find some different level of thing, right? And I think at a minimum, most folks right now are looking at what the project discovery folks are doing, seeing what their scanners are doing, which are all open source, and at a minimum doing that, whatever that is, right? So that's bare minimum, right? It's kind of like running mmap. So that seems to be the thing, right?
Hmm. So when you're also an offensive security professional, so I guess you've done a lot of pen tests of cloud environments. Let's say you have a foothold in a cloud. What are some different ways you can escalate your permissions and gain more unauthorized access and really demonstrate impact? I guess this also counts when a real attacker is inside the cloud. How do they typically, or what are some different kind of attack paths that they might take inside of, let's say, AWS or Azure?
You can call the help desk and ask for the admin password. You kid, but I kid, but that is actually a vector that I've seen used. Please give me the admin password. But okay, so this is where it becomes really interesting. Persistence in the cloud and elevating access, different things, right? So let me try to break this down in a way that the audience can maybe picture this, right? Typically, when we say account escalation, we're saying user to admin, right? Because that's usually the two levels of access that you get, right? In the cloud, it's not really priv-esque, it's a lateral movement, right? So it's lateral access. So I might be able to run EC2 here. I might be able to run Lambda with a different identity. Those are two different services. One is not more escalated than another. So it's not elevation, it's kind of like a lateral thing, right? So what are attacker groups doing? Well, that's where it gets interesting. If you want to do something interesting, you want to persist. So a couple of ways that I've seen attackers persist. One is they try to use features that you seldom find in an enterprise. So for example, I've seen attackers use AWS Lightsail, which is like their DigitalOcean service, which has way less features than, say, EC2. I have also seen them try to use different services like sending email, right? Because your domain is already good to the world. Why not just start sending phishing campaigns, right? You can hide in Lambdas. You can hide in glue services, right? So I've done this before where I set up a Lambda. The Lambda has a way of triggering it from the internet using a specific API key or some other mechanism. And the output of the Lambda, what the Lambda returns to me, is an ephemeral AWS key with elevated access, right? And so now remotely, I'm triggering Lambdas to give me elevated access from the internet, and then I'm back in your environment. And most people cannot figure out what is part of Lambda and what isn't, especially if you have like 5,000 Lambdas doing different things. It gets kind of hard. Also, what data center in Amazon, what data center are you running, right? So all these things are nasty and are ways of persisting in AWS. You could do the same similar thing in Azure. You could do the same similar thing in Google. Google actually has a couple of other things like Cloud Run, where they can do Docker containers as a triggered job service. So you could do long-term, short-term access for the container using Google Cloud Run. In Azure, you also, or in any OpenID Connect system, you have the ability to install applications and or basically applications or service principals. You can use tools like GraphRunner or your own tool set to install a service principal, which is like a service account, or to install a application like GraphRunner in which you are able to really persist in that environment and gain access further in that environment, right? So now you're going to have to audit all your applications or all your service principals to find how this identity is able to abuse your system. And you can give these service accounts access to different parts of Office or different parts of SharePoint, etc., or into Azure itself. And so these are just some of the persistence mechanisms that I've seen. Really, really nasty to find them. Also pretty difficult when you start to federate things and do cross-account tenancies. Like if I take a VM, an AMI, there's some research done around this already, but if I take an AMI and I publish an AMI in your account, or if I publish an AMI that looks like something you would run in your account, you might be able to backdoor it. So there's all sorts of things in there. The end result is you should know every resource that is in your cloud environment. You should track it and audit it. And then you should be able to figure out what's changed and who changed it. That's really ultimately what it comes down to. Super difficult problem to solve.
Yeah, that's the thing I see. I've seen a lot. Might be some developer that spun up a tenant or something way back in the days, and just a bunch of manual deployments, no traceability, no infrastructure as code, and so on. And then a bit down the road, the business is maybe dependent on a certain architecture, but there's no traceability, there is no nothing. Then you're stuck there. So one thing is penetration testing cloud environments. It might be having an identity, trying to see what kind of access does it have, can I move laterally, and so on. But then there's also another thing that only, I guess, more mature organizations can benefit from, and that is actually red teaming a cloud environment where detection also becomes a factor. Uh, what are your thoughts on red teaming cloud environments?
So they asked me about this. There was a contract that we were looking at a few years ago where the customer told us they did not care what we did in the cloud environment. I was like, "Are you sure? I get full like legal indemnification, right?" And they would not let anybody know that we were there, and we had a year to operate, right? Um, and so we started thinking like, what could we do in a year, right? And what's really fascinating is that if you really actually have a long, long time to persist in a cloud, you can hide in places that people would not ever know you were there. There's undocumented APIs that don't leave a trail that people keep a track of. For years, Microsoft Graph went completely undetected unless you were logging was with Microsoft because Microsoft was the only one that could see the graph logs. Um, there are there are things you can do. For example, let's say you take an AWS S3 bucket. Okay, everybody's got these things, right? If I take that AWS S3 bucket and I replicate it to my account in the same data center, in the same environment, I'm not going to incur an egress fee from S3 because I'm only going bucket to bucket. And once it leaves your account and comes to my account, you've lost track of that. And the only real way to see that, to my knowledge, still today, is to turn on object level auditing, which is super noisy in AWS, right? And this about it. You could do this in Azure and in Google Cloud as well. And so you could actually just sit there and be very silent and do this stuff and copy all sorts of data off of the environment. And any service that does cross account copies like this becomes weaponizable by an attacking group. They don't have to be, and they don't have to be noisy. They could do this really slowly over time. The other thing you could do is you could set up like cron jobs in certain accounts. So in Azure Automation, you can persist in Azure Automation by setting up jobs such that we watch certain actions on a host, and once something happens, we trigger an Azure Automation job. Or in Google, you have this concept of Cloud Run and Cloud or not Cloud Run, I'm sorry, cron jobs. And cron jobs work exactly like Unix cron jobs. So you can trigger cloud actions on an interval, right? These are places where most individuals that have cloud security posture management or CNAP may not have detections around, right? So even then, and I still find that many companies lack this capability. They just don't have it. Or if they have it, they're not looking, right? Or they don't understand what it is. So I think the way that I always express this now, I launched the cloud penetration testing class in 2020. We've been doing it for a while. When I launched it, I felt that we were doing 2000 style hacking, where all the attacks you see today on Windows, the ones that are like Bloodhound, all the C# tools, all these tools, they were in Windows, in Active Directory from the beginning, right? Bloodhound stuff was in there from 2000, right? We just didn't have the tool sets to visualize it, right? And we didn't have the understanding to visualize it, like all the Kerberos stuff and everything. So we're like that in the cloud today, where we're just getting our feet wet. We're trying to understand it. We're getting better at it, but it's 20 years after cloud has been out. There's a ton of people doing it, and now it's like, now what? Yeah. Anyway, that's just kind of the way that I look at the red teaming stuff. If you are not adept at it today, don't fret, because it's niche. It's kind of like web hacking in the 2000s. Today today if I talk to a penetration tester, a lot of them will say, "Oh, I started off in web hacking," right? When you talk to most people from back then, if I were to tell you the crazy stuff happening in web hacking in 2000s, you'd think it was a joke almost, right? I was asked the other day, like, what's your favorite hacking tool of the day, right? And the answer was Firesheep. Do you ever heard of Firesheep?
Fire sheath? No, actually, I don't think so.
Firesheep.
Fire sheep? No, actually, don't really. I don't think I've heard of
Okay.
it.
So just to give you an idea of the reference point, right? So why is hacking like early 2000s? Firesheep was a Mozilla Firefox plugin that sat on the side of your web browser. And if you sat inside of a Starbucks or any public Wi-Fi area, you'd start to see everyone's social media account showing up in the sidebar of your browser, and you'd be able to click on it and become them. Now, why was that a thing, right? Like, you're like, wait, why? What are you talking about? Like, what magic is this? It's because the only thing encrypted back in 2005, 2006 was your password. So when you logged into a website, everything was unencrypted. You put in your password in an encrypted form, and then everything else was unencrypted again, including cookies. And 90% of the people, 95% of the people out there that were doing hacking, they didn't necessarily put together the fact that, oh, the actual credentials are the cookies anyway. They're clear text. They're just flying around, and I could just steal them. So Firesheep kind of helped educate people on that. But that's just how things were. Now we're like, of course, everything is encrypted. Duh, like, but it wasn't always like that. So the cloud is kind of like that today, right? Of course, we wouldn't do X, Y, Z. Yeah, you do, right? And so when you're saying red teaming and persisting in the cloud, we're starting to see some of that now. I don't think we're seeing all of it yet. Okay. I'm going to post a video in a few weeks about some really interesting ways of doing C2 in the cloud. So just an example.
Very cool. Definitely
Yeah.
looking forward to it.
Mm.
So yeah, the whole landscape has changed a lot. It was interesting to hear how you started out as a network engineer. You were working with firewalls and you used physical books. Sounds crazy today, but of course that was how it was. So I was just thinking about the topic of people who want to get into this field. So a lot of people, they pen testing, it's very hot right now. You mentioned that as well. It's a lot of people who want to start in cybersecurity because hey, they saw some kind of Hacker Man movie or something, and they think it looks very very cool, and they try. And yeah, they start to read some blogs maybe here and there, but a lot of people maybe get stuck also just watching tutorials and never getting their feet wet, so to speak. So what would you how would you I guess
Recommend.
mentor someone or guide someone along today in with the resources we have available, and how would you I guess yeah help them from beginner to intermediate and then advancing towards researching and really achieving mastery within offensive security?
You're not gonna like the answer. You're not gonna. No one is gonna like the answer. Um, I've done this two ways. Um, I thought about this. We actually hired a few people right out of college. Um, Context. That's the problem. So college does a good job of giving you. Well, okay. Um, Computer science degrees and cybersecurity degrees in college, um, not the same. Okay. I think computer science is definitely a discipline. It's something that a doctor level you'd want to do, right? So if you want to do algorithms and you want to do programming at a deep level, I think computer science is great, and it gives you a foundation that is unmatched. Most of the work that we do, oh God, this is going to offend some people. Just hear me out, right? Most of the red team operators, the network engineers, the system admins, those folks are those are job skills, right? Those are job skills that you can that are like a technical school kind of a thing, right? Like kind of like a technical training thing. It's not a it's not the same theoretical level as a computer science person. Does that mean that I think people shouldn't do computer science? No. But you have to understand that most of the world today is operated, secured, and defended by people who have a trade level set of engineering classes, and that's fine, right? They understand Windows and how to install it. Okay. So anyway, I take a computer science slash cybersecurity person out of school, and I bring them into the environment. And the questions that they're going to have, and they have had, are how does LSAS work? What the heck is Active Directory? What is NFS? What's a storage environment? What's a SAN? What do you mean? What do you mean? The other day was what print to email? What the heck is scan to email? I don't even know what that is. So there are these grunt level things that you learn about when you are a system admin, when you are a help desk person, when you are a desktop architect, when you are a network engineer. You got to go through that. You got to go through some amount of that, whether it's a year or two of that, before it can properly dump you into into a hacking thing, so that you have context. Because how would you know? How would you know that if you locked yourself out of a desktop and you called the help desk, this happened to me, by the way, you lock yourself out of a desktop and you call the help desk, that their only mechanism to unlock you would be to send you the administrator password of the laptop to log in? How would you know that if you didn't work at a help desk? You wouldn't know that, right? So if you do it, if you want to do this, I'm being honest, if you want to do this, go find yourself an enterprise job. I'm not saying work at a help desk at a MSP necessarily. I mean, even though that might be good, find your way into an enterprise, work at help desk, desktop, change. I started by changing light pens inside of a help desk. I was the printer changing person, right? That's how I started, right? Be around, volunteer, help out. Hey, do you see a system admin? They're doing some work. You say, I want to learn what you're learning. I will come free. I won't go to, I won't ask for any extra money. I just want to learn what you shadow you, right? That's what we need more of, because I can take a system admin that knows how the system works, and I can make them an offensive person easier than taking somebody out of school and doing it, right? And that sucks for a lot of kids to hear. I understand. They want to instantly be the hacker, and there are people that have done it and they're pretty successful at it. But I think you miss context that way. That's all.
Yeah. Really understanding how business works, I guess, especially for red teams, that would be a big thing, as you say, that it's really that easy for the help desk administrator to just reset your password or whatever, and having that intuitive hands-on experience with Windows, with yeah, how all of these things work if you're testing on-prem. I guess also having a developer background is something I've heard is probably very beneficial for people who want to work with also cloud security later on.
And web. Like if you are a developer and you know how to write code, you would make a better web app pen tester. Like my co-author, Aaron Cure, for the SANS course, he is a .NET C Sharp. I know it's .NET. That's a language, I guess. He's a .NET C Sharp web developer, right? I just like giving him heck. But he's that's his background. So getting into web app pen testing was a lot easier for him because he understood how it works inside the hood, right? What to look for.
Yeah, because there are a lot of online labs as well. Some people, try hack me is a thing, hack the box is a thing, and there you get some practical experience there as well, I guess.
Yeah. I mean,
Mm,
I don't want to say that you cannot do a try hack me or that you cannot do a hack the box, or you cannot do classes to try to get you up there, right? But realistically, how many of those classes have implemented an enterprise voice over IP system with switches and routers and stuff, right? How many of them have implemented a wireless control? I'm not even going to say Cisco. I used to work there, right? Let's say Aruba Wireless with ClearPass and Radius. How many have done that? How many know that most NAC systems have MAC address bypass? Right? These are just things that you don't really understand until you've actually implemented these systems or worked with them, right? And there is currently no course that I've seen where it's like, okay, here's an enterprise network, here's all the components of it, and you're gonna hack it. It's very rare to find that.
Hmm. And when we're on the topic of learning, one thing that I feel is making things a lot easier for new people wanting to break in is actually AI and the AI chatbots and how they can make you a learning plan, they can be your tutor, they can be your anything, basically. So I guess AI is great for learning, but I'd also like to hear your opinions on AI and how that it has been a thing in cybersecurity for a while, of course, and now you have all these people running around. Oh, the latest Chinese AI, it's making exploits, and it's everything is over. People are just blowing things out of proportion, maybe. So, what are your thoughts about AI, both in offensive but also the opportunities in defensive cybersecurity?
Well, okay, do you want to know about AI? Well, let's see, AI or quantum? Which one would you want to take on first?
Which
Let's
of
do,
the
let's do AI.
buzzwords?
Let's do AI first. Let's do AI. We can talk about quantum in a bit. All right. Um, okay. I think AI is either going to be really amazing for us or really bad. Now, or both, maybe. I don't know. The two things could be true at once, right? Um, Deep research, or the concept of deep research, the idea that an AI system can do things. Actually, you know what? Let's take a step back. Most people probably that have done some pen testing have run across some of the online Git books that are out there. There's one called, I think, hacktricks.xyz. It's very common in the search engine. Whenever you try to search for something, you'll see it at the top, right? Now, it's a great resource. They put a lot of effort and time into it. They've been able to aggregate things and put them in a database, etc. And the reason that this becomes interesting is because there are so many things you have to know to be a good pen tester and an offensive person that you will forget. You will ultimately forget things, right? So, what is it about AI that makes this kind of different? Done right, right? And I don't think we've seen this yet. AI brings two things into the table that we have not seen with search. The first is context. AI does a good job of learning context, right? So if I say, hey, I'm hacking this IP address and I want to know what exploit to use, right? It might already have the context that I had a scan, that I had this, that I had that, and start to help piece together. So I think as a assistant, these AI engines that do some kind of context and also research could be interesting, right? The idea that, hey, ChatGPT or whatever, I don't even want to say the LLM of choice. I don't care which one it is. You say, hey, I want you to go out and I want you to start searching these data sources for the best attack path given this set of items, right? What it can do is it could take what I would see as a multi-hour, multi-day process and help me expedite it. All right. Now, do I think it's going to replace me? Right. To some extent, it's going to do the trivial stuff. I think right now there is not enough understanding of what it can do to replace me. That's number one. Number two, at what cost? So right now, does it cost me more or less to run AI in part of a pen test than a human? But then again, we're in 2025, and I think part of the reason that it's so expensive is that what we're really doing is we're taking paper, we're taking PhD level papers on theoretical science that was defined in the 80s. It was defined in the 50s and the 80s and in the 2000s. And we're just throwing a massive number of GPUs at it and saying, look, we can scale because of how much compute we have, right? So at the moment, that's how it's working. But if everyone in society started to use these AI models in the back end, we just don't have the chips to do it. We're going to have to choose. We're going to have to start picking and choosing what is AI, what parts of AI should I be using and what not. Just to dovetail that, I was at Consumer Electronics Show, and it was Consumer Electronics Show this year in Vegas, and everything was AI. Everything. I mean, AI, everything. AI slop is what some people call it. Just AI for everything. Some of it made no sense, right? Some of it was like, hey, I'm going to what was it? It was like, hey, I'm going to send you ads off of a radio in your car through AI, targeted. That's what it's going to do. Mind you, it's going to cost you more money to run those AI models than the actual make the revenue off the ads. But whatever, it's AI. You'll buy the radio. Doesn't make any sense. AI bassinets, crazy AI things, right? So just like everything else, we're going to have to pick and choose what we use AI for. And there's going to be some things that are going to be very beneficial for us, and there's going to be some things that maybe not so much, right? Like, would I want my AI system to run Nmap? Probably not. Would I want it to aggregate a bunch of files together, reason it, summarize it for a report? Maybe. Maybe that's a better use. So early days. If you are not using AI, you should. You should learn all the. It's so fast paced that you should take some time to look at it every day. I was looking at Grok the other day. I was looking at Klein. But just take a look at it. I think it's early days. Here's what I'm excited about. Let me just give you. Here's an exciting use of AI. If I take a heavy JavaScript app, React, I don't know, something I've never seen before, and I throw it at ChatGPT and I say, hey, Chat, or whatever. I throw it at an LLM that has a RAG, and I say, look, I'm looking for all the places in this file where I can shove data or change a URL. And it says, okay, here you go. Here's out of the million lines of code, here's all the ones you're interested in. Fascinating, right? That's a good use of the system, right? So hoping that we can do some of that would be interesting, to say at least.
Hmm. Yeah, because many of these AI models they excel at code, so that's definitely a use case that we have right now, and will probably be more relevant as time goes on. Yeah.
You know, it's an interesting one also, like for since you're in Europe. I would love to be able to have a real-time earbud so that I can walk around and like not have to know Norwegian, and it would just translate for me. That would be nice.
I think that actually exists. I'm not sure about the latency, but there's some kind of startup that works on it actually. It's called like Babel or something like that. So yeah,
Yeah, there you go. Yeah, yeah.
very
Because
cool use case.
no offense to anybody in Norway. It's just not in my wheelhouse right now.
Yeah, not the most relevant language maybe.
I don't know. I mean, I know English and Spanish natively, and I started picking up German as an adult, and that is not easy to pick up. I'm just gonna tell you this right now. That's a really hard language. I don't know how people in like. Then there's Dutch, which is like bizarro German. I
Yeah, I ended up also bringing up quantum there because just why not? Let's just put in all of the hype that's
This
going
is the
on.
hype,
So
right?
yeah, yeah. You also talked about TLS 1.1, and I guess with quantum that becomes more of a severe vulnerability. So yeah, there's breakthroughs happening. What are your thoughts?
Well, so here's why I think quantum and AI kind of come together. Okay, so Microsoft came up with this chip about 2 months ago, a month ago, and the idea is it's called a topological quantum processor. So um, I'm not a quantum physicist, so I'm going to do the layman's version of how I understand quantum computing to work, and why we think that it's going to be groundbreaking. And then the other thing is, how would this impact AI? Will this impact AI, right? So, first of all, for the audience, the first question that I had, and I'm sure everybody else has it, is, so I'm going to have a computer that's quantum, like replacing my Intel CPU on my laptop? And the answer is no. The quantum processor, if you could have it miniaturized, which you can't right now, the quantum processor would run like the GPU runs. It's off the side. Okay, so that's how that would work. Okay. The next question is, what the heck is a qubit? You keep hearing about qubits. What the heck is a qubit? All right, well, so you have a 0 and a 1, and that's how we do computing today, 0 and 1. A qubit, think of it as a three-dimensional sphere, okay, like that, right? And you can have the, think of it, think of it like a clock. Let's do that. That's easy, right? So three-dimensional sphere points up for 1, points down for 0, and it points in every other three-dimensional space for other things, right? For superposition of 0 and 1, okay? That by itself doesn't mean much, okay? So what happens is you pair up these quantum bits, and by the way, if you want, if your audience is interested, you go on YouTube, you can find a bunch of ways of looking at quantum computing and how it works. But basically, you pair up these qubits, or these 2 bits, and they emit, you line them up, and they emit a probabilistic qubit. So they say, 50% of them are 1, 20% of them are 0, 10% of them are 0.5 or 1.5 or whatever the number would be, and then so on and so on and so on. And it becomes a probability matrix. Okay, that in and of itself is how a quantum machine works. Okay, the problem is that quantum machines fail when there's interference, such as background radiation, noise, etc. That's when they kind of fall apart. And the fact that there's some theoretical components of quantum mechanics where you cannot clone a quantum state. That is a principle of quantum mechanics. So you really can't have error correcting bits like normal. So there's actually ways of doing error correction, but it's very, very, very expensive, as in you need a lot of qubits to correct 1 qubit. I think it's like 100 to 1 or something. Anyway, so what does this have to do with, like, let's say us, right? What does this have to do with our field of science, our security field, right? Well, there's a gentleman in the 90s called Shor, S-H-O-R. Shor's algorithm, basically what it does is it's actually simple math if you really look at it. It's a simple mathematical formula that if you guess a number, well, actually, let's step back. The way that TLS works today, and we got to step back for your audience to kind of understand this. The way that most of our modern cryptography works today is that you have a big number, 10,000, 768 fields, whatever that number is, big number. And for you to figure out the 2 prime numbers that derive that big number would be exponentially difficult to do, okay? So prime number factorization for large numbers is expensive. It takes a lot of time. It could take thousands of years, etc. And that's how most of your cryptography works today. So if you look at RSA, that's how RSA works, okay? What Shor's algorithm does is it came up with a shortcut in which you can, using quantum mechanics and quantum field technology, you could actually go in and figure out what those 2 prime numbers are quickly. But it requires about 1 million qubits, and it does actually theoretically work. Like, you can actually run Shor's algorithm today on your computer, and if you use a small number, it'll derive the 2 factors, okay? So when somebody comes up with a prime number, basically a quantum machine that has enough capability to do 1 million qubits, they say that most people that have captured cryptographic messages should be able to decrypt some amount of them. Okay, there are some other dependencies on that, but that's the fear. Because of that, people have started to create quantum resistant cryptography. Cryptography that uses something other than prime numbers, such as lattices and other things. So that's how that would relate to security. So the question then becomes, all right, if we have a quantum machine, will some of these math problems that we are trying to solve with LLMs become quicker, right? Because what an LLM is doing is it's using linear algebra to go through its database and take a token and transform it to another token, right? So will that process become quicker and use less compute power in the world of quantum? We don't know, but what we are starting to see is more and more companies race towards a quantum processor. And I think we might be closer than I theorized. By the way, I theorized that we were like 100 years away. So we might be maybe closer. I don't know. I don't know. Stick one in space. I'm sure that would.
Yeah. What's definitely a sure thing is that, as you say, AI is moving crazy quick, and if we throw in, yeah, as you say, these exponential improvements from quantum as well, things might just go off the shelf. So we'll see
Yeah.
how these next few years. Like my time horizon is probably more like 10 years, more than 100. Just things
No,
are
no.
just absurd.
Yeah. The problem with quantum machines today, and the reason that this topological machine was so important to Microsoft is because first of all, topological particles are theoretical. So Microsoft Jimmy rigged. They created a pseudo topological particle by lining up a bunch of electrons. So that's what they did. Very, 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 very innovative in the field of quantum mechanics, right? But it's less. It's got less. The properties of a topological particle, in theory, would be less susceptible to interference. So the idea is, if we can eliminate all the interference from the machine, the quantum state would hold up for a long period of time and the calculations would finish. So I don't know how far ahead we are from that today. I don't know if you've ever seen those quantum machines where it's like a canister, it looks like a big triangular canister. The reason that those exist is because it's kind of like a Russian nesting doll, where it's like a canister and a canister and a canister and a canister and a canister, and each canister they remove the vacuum of, right?
Mm.
And so there's less and less interference inside each one, and that's what it would currently take to have, I think, like 48 qubits or something. So I don't know. I don't know how far away we are, but it's going to be interesting for sure.
Yeah, I will definitely be interesting. I've learned a lot through this conversation. It was very interesting to finish off with quantum. I just saw looked at it more like a buzzword thing, just like I probably looked at AI 2 years ago. So yeah, another thing to be scared about, and another thing to watch very closely. So thank you very much for sharing about that as well. And thank you very much for coming on the podcast, Moses. It was first of all, I just want to give a shout out to your new YouTube channel, the Moses Frost Show. I'm a new subscriber there. You're sharing daily content there, right?
Yeah, I am. So I am trying to do 5-minute videos, topical items uh, on YouTube and on LinkedIn, mostly on YouTube. And then eventually I will do some long form content. Some of it might be technical walkthroughs, others might be interviews. If I do interviews, I want to make sure that they're guests that I would have fun interviewing. People that work in the computer industry that you're like, huh, who wrote this thing or who designed this thing? I want to do something kind of new around that. So if I do that, it should be fun. It would be seasonal if I do that. But I don't know how you do it. It's very time consuming. I barely have enough time for life, and making video content is definitely another skill set and a very time consuming one. So I applaud you for doing it.
It's a great way to use the other half side of your brain or something. You know, the creative side. I know pen testing is creative, but it's a nice hobby, and looking forward to seeing your content as well as time goes on. So, what other places can people find you at? I know you're on LinkedIn.
Um, I'm on LinkedIn. I'm on all the social medias. If you look for Moses Renegade, you will find me on all the social medias. I will send you my link tree. I mean, anything, Blue Sky, Threads. I figure I register myself on other social medias, whether I use them or not, just so that I can have a beachhead.
Yeah, also occupying the tag so no one else takes it.
Yeah.
Awesome. Thank you so much, Moses, and have a nice day.
Oh, I appreciate it.
Bye.